These are your instructions. In general, you just need to follow the PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on the relevant slides. Don't forget, if a slide asks for homework, send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given. Our lesson objectives for this lesson are just to revise Hooke's law. This is a question you were set last week. We're going to go through it now step by step so you can green pen it. Part 1. The independent variable is what we change during the experiment. In this case, it's the number of masses that we hang from the spring. A control variable is something that we keep the same to make sure we are carrying out a fair test. So for part 2, you could have said the ruler that we were using to do the measurement or the spring itself. Part 3. When a force of 4 newtons is applied, the spring extends elastically by 2.5 centimeters. Calculate the spring constant. Now, there's a couple of points you need to be aware of here. One, that measurement, 2.5 centimeters, needs converting into meters. Otherwise, you won't get the correct result from the formula. 2, that formula for Hooke's law, F equals KE, only applies if the spring extends elastically. That's why they've specifically mentioned that in the question. So, in this case, we know that the force is 4 newtons, and we know the extension is 2.5 centimeters, or converting it to meters, 0.025 meters. Then we know our formula, F equals KE, which we can rearrange to give K equals F divided by E. Substitute in the figures, put it into your calculator, and you get K equals 160 newtons per meter. Part 4, a force of 15 newtons is applied, and when it is removed, the spring is 7 centimeters long. Its original length was 5 centimeters. What has happened to the spring? So this time, when they've removed the weights, the spring is no longer its original length. And that should be the clue that you need to say the spring has gone beyond its elastic limit, or you could say it's gone beyond the limit of proportionality. They mean the same thing. We're now going to do a worked example on Hooke's law. Stop the recording here and have a look at the PDF that's attached. Don't panic, it is a massive question, but we're going to work our way through it one part at a time. So a student carries out an investigation to determine the spring constant of a spring, and the data is given in the table below. So what you have in the table is the student has changed the force, increasing it by 2 newtons each time, and he or she has measured the extension in centimeters and recorded that in the table. Part A, describe a method the student could have used to obtain the data given in the table above. Your answer should include any cause of inaccuracy in the data, and it may include a labeled diagram. Now, before we look at the actual steps in the experiment that the student could have carried out, this is some information from the exam board, and they've graded students' answers to 3 levels. There are 6 marks available altogether. A level 1 mark would have got 1 to 2 marks. The method would not lead to a valid outcome. Some relevant steps are there, but the links are not clear. A level 2 answer would have got 3 to 4 marks. The method would not necessarily lead to a valid outcome, so it doesn't need to be perfect, but most steps are identified and the method is not fully logically sequenced. So they could have got some steps out of order. Level 3, that would have got you the highest marks, 5 to 6 marks. The method would lead to the production of a valid outcome. All the key steps are identified and they're logically sequenced, which means they're in the correct order. Now, as always with these questions, there are lots of things that you could have said, but here is some what they call indicative content. So if you had said any of these steps, you would have got marks for it. Set up a clamp stand with a clamp and hang the spring from the clamp. Use a second clamp and a boss to fix a ruler alongside the spring to do the measuring. Record the meter ruler reading that is level with the bottom of the spring. Hang a 2 Newton weight from the bottom of the spring. Record the new position of the bottom of the spring. Calculate the extension of the spring or measure the extension of the spring. Add further weights to the spring so the force increases 2 newtons at a time up to 10 newtons. And for each new force, record the position of the bottom of the spring and calculate, measure the extension. So you wouldn't have got all of those, but you would have got marks for the ones you got. Now the question asks for some possible sources of inaccuracy, and here is some indicative content. So if you hadn't fixed the ruler in position, but were simply holding it there, then it's difficult to make sure you're holding it in the correct place for each subsequent reading. So that could have been a source of error. If you don't have the ruler vertical, then that could be a source of error. If you misjudge the position of the bottom of the spring, that could be a source of error. What they mention here as something called parallax error is if you are not at the same level as the reading you're trying to take and are slightly above or slightly below, then your readings can be slightly inaccurate. That is called a parallax error. A diagram of the apparatus used would look something like this. The next part of the question says the student measured the extension for 5 different forces rather than just measuring the extension for one force. So why? Why do the experiment repeated 5 times with different masses rather than just doing it once? And the answer to that is so you can identify any anomalous results or to calculate an average for the spring constant. The point here is if you only do the experiment once and you make a mistake on it, then how are you going to know that you've made a mistake? If you do it a number of times, you will be able to spot the anomalous result. The next part of the question asks you to complete the graph that the student has started. So here's the graph again, slightly bigger, and for the sake of convenience, I've taken the student's data and added it here. On the graph, the force in newtons goes across the x-axis and the extension in centimeters goes up the y-axis. If you look at the points that are already here, they have come from this table, but there are 2 points missing. Our first job is to put those points in. So that's my first point, and that's my second point. Those are the 2 missing points I've put in, and now I need to draw a straight line of best fit through the origin, and that looks like that. So this is what you would have got marks for, both points plotted correctly, and for drawing a line of best fit through the points 0, 0 and 10, 20. The next part of the question is relatively easy. Write down the equation that links extension, force and spring constant. And you should have written force equals spring constant times extension. You would have got the mark for saying F equals KE, but please remember that your capitalization has to be correct. Part E asks you to calculate the spring constant of the spring that the student used and give your answers in newtons per meter. Now I've copied our graph here onto the left-hand side of the page so we can refer to it. You can work out the extension for the force at any point along that straight line, which means you can work out a value for K at any point along that straight line. So you could do it here, 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 here. For the sake of convenience, I've used this point because I know when the force is 10 newtons, the extension is 20 centimeters. First thing I do is change that extension to 0.2 meters, which means I know F equals KE, the force 10 newtons equals K times the extension 0.2. Rearrange it, substitute in the figures, and your answer will be K equals 50 newtons per meter. So the last part of the question, Hooke's law states that the extension of an elastic object is directly proportional to the force applied, providing the limit of proportionality is not exceeded. The student concluded that over the range of force used in the experiment, the spring obeyed Hooke's law. Explain how the data supports this conclusion. So the 2 points you want to make about this answer is 1, that the line is straight, and 2, that it passes through the origin. Don't forget to complete your EduCake and have it done by Monday, the 4th of May. Thank you.